Hello everyone, welcome to the GATE series of S.A.E. Engineering College. Myself E.Lavanya, working as an Assistant Professor, Department of Electrical and Electronics Engineering. Okay, this is the GATE syllabus of Analog and Digital Electronics. In that I am going to take the part as multiplexers and demultiplexers. The multiplexers is otherwise called as MUX and demultiplexer is otherwise called as DMUX. Multiplexer and demultiplexer topic is very important for the GATE syllabus as well as the GATE exams. Before going to the topic, we will see the outline of MUX and DMUX. In that we are going to see about the introduction, digital logic gate symbols, multiplexer, block diagram of multiplexer, then applications and truth table of multiplexer and demultiplexer. This is the digital logic gate symbols. In that we are going to see the AND gate, OR gate, NOT gate, NAND gate, NOR gate and XOR gates. The AND gate is the multiplication operation, OR is the addition operation, NOT is the complement and NAND is the inverse process of the AND gate and NOR is the inverse process of the OR gate. The last gate is XOR gate. This is the multiplexer. The multiplexer is otherwise called as MUX and it is also called as the data selector. The term multiplexer means many into one. That means many indicates the 2n number of input signals and one is nothing but it will generate only one output through the help of select lines. The second point is the multiplexing is the process of transmitting a large number of information over a single line. Then it is a combinational circuit. Multiplexer and digital it is a combinational circuit that select one digital information from several sources and transmit the selected information on a single output line. That is many into one. Many means 2n number of inputs and it will generate only one output through the help of select lines. Then a multiplexer, it is also called as the data selector. The multiplexer has several data input line and a single output line. It is a parallel to serial conversion. The multiplexer is nothing but it is a parallel to serial conversion. Then it is also act as a digital switch. In continuation of the multiplexer, MUX directs one of the inputs to its output line by using a control bit word. The control bit word is nothing but the selection lines. Using selection lines only, it will generate the output line. Then the multiplexer contains the three following steps. One is the data inputs, second one is selection input, at last third one is a single output. Then the selection input determines the input that should be connected to the output. It will accept, the MUX circuit will be accept the many input lines but it will be generated only one output line with the help of selected lines. The multiplexer acts like an electronic switch that selects one from different. This is the block diagram of multiplexer. Okay, this is the basic block diagram of multiplexer. Multiplexer contains many input lines and it will generate only single output through the help of select lines. That I am going to draw the basic diagram of multiplexer. This is the basic diagram of multiplexer. This is the selection lines. And this is your output. This 4 inputs is your input signal. And these 2 lines are several number of, that is n number of lines, n number of selected lines and y is your output. This is the basic block diagram of multiplexer. Okay, this diagram, this block diagram of multiplexer is nothing but 4 cross, that is 4 cross 1 multiplexer. 4 cross 1 multiplexer. This block diagram indicates the 4 cross 1 multiplexer. These 4 are input signals. This is your output, and this is the n number of select lines. The 2n represents 2 to the power of 1 equal to 2, 2 to the power of 2 equal to 4, 2 to the power of 3 equal to 8, 2 to the power of 4 indicates 16. That is, it has several types. The multiplexer has several types. That is 2 cross 1 multiplexer, 4 cross 1 multiplexer, 8 cross 1 multiplexer and 16 cross 1 multiplexer. This is the 4 cross 1 multiplexer block diagram. This is the 4 cross 1 multiplexer logic symbol. Okay, this is this 4, D0, D1, D3, D4 are the data inputs, that is n number of inputs. This is your D1, D2, D3, D4 is the n number of inputs. This one is your single is your data output. Then these two are the select lines, that is S1 and S0 are the select lines. This is the 4 cross 1 multiplexer logic symbol. This is the truth table for 4 cross 1 multiplexer. The multiplexer will accept many input signal, but it will generate only one output signal through the select lines. This truth table of 4 cross multiplexer will depend upon the selected inputs. So we are writing S1, S0, then Y is your output 0, 0. Then 0, 1, 1, 0, 1, 1. This is the selection lines S1 and S0 of the block diagram from 4 cross 1 mux. D0, D1, D2, D3, the last output. This is the selection lines. This 4 is the input lines. This is the output lines. This S1 and S0 are the selection lines. One input signal will give the only one output signal through with the help of selection line. So 0, 0 means D0 only will appear. 0, 1 what the input will given, that only the output will be appear through the selected lines. If 0, 1 means D1, 1, 0 means D2, 1, 1 means D3. This is the truth table for the 4 cross 1 multiplexer. Now we are going to write the logic equation for the 4 cross 1 multiplexer. Logic equation for the 4 cross 1 mux. So your equation will be Y equal to S1 complement S0 complement into D0. Your output will be S1 complement S0 complement into D0. Then plus S1 complement S0 into D1 plus S1 into S0 complement into D2 plus S1 then S2 into D3. This is the equation of 4 cross 1 multiplexer. So Y is equal to output is Y equal to, this is the, you have to write from the selection lines. S1, so 0 means complement, 1 is your S1. So S1 complement into S0 complement into D0 plus 0, that is S1 complement into S1 into D1, S1 into S0 complement into D2 plus S1 into S0 into D3. This is the equation of the 4x1 multiplexer. For this equation, we are going to draw the circuit diagram. Okay, this is the circuit diagram of 4x1 multiplexer. Your equation is what? Your equation is y equal to S complement, S1 complement into C0 plus S complement into S1 into C1 plus S1 into S0 complement into C2 plus S1 into S0 into C3. This is the equation for the 4x1 circuit diagram. Okay, first how you draw the circuit diagram? S1 complement. First you have to draw the two select lines, S1 and S0. This is the two selection lines. Then you have to take the complement line. Complement line you have to draw like this. First you have to draw the selection lines, two selection lines, S1 and S0. Next you have to draw the complement lines. This is the complement lines. Okay, we have to draw the diagram. First you have to draw this two and next you see the equation. This is your output. Okay, this is output. First what? S0 complement into S1 complement into C0. How? S0 complement into S0 complement into C0. This is your C0. You have to draw the AND gate. You have to draw the AND gate. Next, S0. S0 complement then into S1. Then you have to draw the output of C1. This then form the AND gate. This is a C0. This is a C1. Next, S1, S0 complement into C2. So your S1 is this, then S0 complement, then one line. Form an AND gate. This is the C2. Then last S1, then S0, then last C3. Form an AND gate. This is the C3. These four AND gates combined form together a XOR gate, OR gate. That is a addition operation. This is your output. Like this, how to draw the circuit diagram for this current equation. This is the 4x1 multiplexer logic diagram. This is our output equation. Y is equal to how S0 complement S1 complement into C0 plus S0 into S1 C1 plus S1 S0 complement into C2 plus S1 S0 C3 complement. For this equation, I drawn the circuit diagram. This is the circuit diagram for the 4x1 multiplexer. Like this you can draw for the 2 to the power of 1 means 2x1 multiplexer. Then 2 to the power of 3 means 8x1 multiplexer. 2 to the power of 4 means that 16 into 1 multiplexer. In that I done the 2 cross 2, that is 4 cross 1 multiplexer. I drawn the circuit diagram as well as I written the equation for the 4 cross 1 multiplexer. This is the 8 cross 1 multiplexer circuit. Okay. The next topic is DEMULTIPLEXER. Multiplexer is many to one and demux is the reverse process of the multiplexer. It is one to many. Multiplexer is mux is many to one and demux is one to many. This is the difference between your mux and demux. Multiplexer is many to one and demultiplexer is one to many. In multiplexer, it will accept many inputs, but it will generate only one output. But in demux, it will accept only one input and it will generate several number of outputs through the help of selector lines. This is the definition of the multiplexer. This is the definition of the multiplexer. The demultiplexer is a combinational circuit that performs the reverse operation of the multiplexer. Demultiplexer means one to many. Multiplexer means many to one and demultiplexer is one to many. It is a circuit, one input and many output. It will accept only one input and it will generate the many output with the help of selector lines. And demultiplexers are also have several types, 1 to 2 multiplexer, then 1 to 4 multiplexer, that is 1 cross 8 and 1 cross 16. As we said in the multiplexer, what 4 cross 1, 2 cross 1, 16 cross 1, 18 cross 1. So this is the reverse process of the multiplexer. So it is 1 cross 2, 1 cross 4, 1 cross 8 and 1 cross 16. And this is the serial to parallel conversion. Multiplexer is a parallel to serial conversion. Demultiplexer is a serial to parallel conversion. Multiplexer is a data selector, but demultiplexer is a data distributor. Okay, that multiplexer will act as a digital switch, and the demultiplexer will act as a digital circuits. This is the basic block diagram of demultiplexer. It will contain only one input signal, but it will be generated the many output signals. That is 2n number of output signals through the help of n select lines. That is S1 and S0. This is a one single input with the help of select lines. It will generate a many number of output lines. This is the basic block diagram of the demultiplexer. Then this is the 1 to 4 demultiplexer logic symbol. Okay, this is a selector inputs, that is S1 and S0 are the selected inputs and only one data input. Data input is only one in a demultiplexer and output will be several inputs, that is n number of outputs. This is the demultiplexer logic diagram. Before that, we will see the truth table for the 1 to 4 demultiplexer. The data input is D, then select input is what? S1 and S0. As we previous the multiplexer we see no, the truth table as it is only, but it contains more input signal in the multiplexer and only one output will be generated in the multiplexer, but in demux it will contain the 4 outputs because this is a 1 cross 4 demultiplexer. The data input is D, then S1 and S0 are the selection lines, then this 4, Y3, Y2, Y1 and Y0 is your output. This is the demultiplication logic diagram. Okay, I will write the equation for the demultiplexer logic diagram. S1, S2 into D, that is into Y0 plus, that is S1 complement. Next, S1 into S2 D into Y1 plus S1 S0 into D into Y2 plus S1 into S0 D into Y3. For this also you have to draw the truth table. This is your S1, this is your S2. 0, 0, 0, 1, 1, 0 and 1, 1. This is your D, that is your data input. Only one input. This is marked as D. Then outputs will be Y0, Y1, Y2 and Y3. This is the output, this is the selector lines, this is your input. 0, this is a D, 0, 0, 0. Then second one is 0, D, 0, 0, 0, 0, D, 0. 0, 0, 0, D. This is the truth table for the 4x1 multiplexer. This is a input. Input will be what? With the help of selection lines, it will give the several number of outputs. Okay, this is the truth table for the demultiplexer. So this is the circuit diagram of the demux. First you have to draw the two selection lines. After that you have to draw the complement lines. At last we have to draw the input lines. Okay, this is a truth table for the 1x1 4 multiplexer. Then at last applications of multiplexer. Multiplexer will be used in the communication system, then computer memory, then applications of demux. It will be used in the communication system. The difference between mux and demux is nothing but mux is many to one and demultiplexer is one to many. It acts as a data selector. It is a data distributor. It is the digital switch and it is the digital circuits. The conversion is parallel to serial conversion and demux is the serial to parallel conversion. The multiplexer has several types such as 2x1 multiplexer, 4x1 multiplexer, 16x1 multiplexer, 8x1 multiplexer. The demultiplexer has several number of types, that is 1x2 multiplexer, 1x4 multiplexer, 1x8 multiplexer, last 1x16 multiplexer. This is the difference between the mux and demux. Mux and demux, this is important for the GATE exams. Okay, now we will solve one GATE problem. It is asked in the year of 2014. Okay, this is the mux diagram. This is the block diagram of mux. Okay, this is the problem asked in the GATE exam in the year of 2014. This is very important topic for the GATE syllabus for the GATE exam. Okay, this is the multiplexer block diagram. This is your input will be W and the complement will be W bar. Input is W and complement line. This is a input and complement line is a W bar. This is your mux. Then this is your select lines. The S1 is your indicates the select lines. So this will be indicated as a A. So A equal to W. W into S1. A equal to W into S1 plus W bar S1. This one is this. This mux diagram is a W complement. Then this S1 is a selector lines. At last the output will be considered as a A. So A equal to W into S1 plus W complement into S1. W into S1 and W complement into S1. So this is rewritten as W plus S1. Okay, W into S1. Then this is the another. This is the another mux. This is what A equal to W S1. This is the A complement. This equation is rewritten as F. So F equal to A into S2 plus A complement equal to A plus or S2. So at last the output will be so A equal to W into S1 plus W complement into S1. That is written as W plus S1. The F equation is A into S2. This two equation is written as W plus S1 into S0. The option is D. D is the correct option. Okay. The next class will be continued in the next session. Thank you.